ACT Math, I should say that ACT Math is a very different exam. And why is it a different exam? Because it tests you on all the perspective. When I say all the perspective, you will get questions on each and every topic, right? When I talk about all the topics, that means it goes to very higher level, right? But it does not touch the calculus part, right? So below calculus, it tests on everything. But when I say it tests on everything, I should say that it is a very shallow test. It is not an in-depth test, right? So when I use the word shallow, right? So what do I mean by that, right? I say that it touches everything and it comes back. That means you should have a knowledge of everything, but in-depth knowledge of everything is not required, right? That is what we talk about ACT Math, right? Now, talking about the, let's say the exam pattern, right? When I talk about ACT Math, yeah. So if I talk about ACT Math, right, how many questions do we have, right? So if I say that it gives you 60 questions, right, and the number and the amount of minutes, right, or the time that it gives you is 60 minutes, right? So technically speaking, right, we can understand that this is one of the tests, right, that actually puts you a lot of pressure in terms of time, right? You get 1 minute per question, right? That means, let's say if you are stuck with a question and if you waste some extra time on one question, right, you might struggle with a different question, right? But I can say, right, the good news over here is that we get something called as a GDC, right? Now, what exactly is a GDC? GDC is a graphing display calculator. Right? Now, when I say graphing display calculator, right, graphing display calculator is a tool, right, that is allowed in the exam, right? Whether it is a TI Inspire, whether it is a Casio GDC, right, it actually helps you a lot in the exam, right? There are certain questions. I should not say that all 60 questions can be solved on the GDC, but I can say that there are certain questions which you can directly solve on the GDC, right? The GDC actually helps you a lot when it comes to ACT Math, right? But you should know, right, how to properly use the GDC. See, for example, you have the GDC in hand, but you don't know which menu to use and where to use, right? You will really struggle with the GDC. So I can say that ACT Math is an exam which is a complete combination of knowledge plus, you can say, the calculator, right? See, without knowledge, you won't be able to crack the question, right? So you know from which topic the question is. You should have the basic information about the topic, and then you should know that how to apply or how to use the GDC, right, in a specific question, right? If these two combinations are there, right, trust my words, right, 60 minutes are also more, right? You will be able to save time, right, when it comes to ACT Math. Right. The next thing, if I talk about ACT Math, is let's talk about the syllabus, right? See, so since I already said that you will be tested on everything, right? Everything will be asked, right? So when I talk about everything, we will have something called as the basic algebra, right? Now in algebra, everything, right? See, for example, in algebra, we will be tested on inequalities, right? You will be tested on progressions. When I talk about progressions, right, I'm specifically talking about AP and GP. The next thing, if I talk about, let's say they will test you on matrices, right? Now, when I again say matrices, right, only the basics of matrices, right? The addition, subtraction, multiplication, and to find the determinant value of it, right? The next thing, they might test you on complex numbers, right? Now, when I say complex number, right, see matrices and complex numbers are certain topics, right, which you can easily deal with the GDC, right? See, again, we have one thing in our mind. If we are a CBSE student or ICSE student, we have the habit of doing everything mentally, right? So ACT is something, right, that puts you again, right, in front of a calculator, right? You should know that which menu to use, where to use, and how to save time, right? Because the time that you are saving in one question, that can be utilized in a different question, which might be a trickier question, right? And again, right, the question that comes in ACT are usually a very simple question, right? The questions are easy, but right, again, right, we have a time constraint over here, right? And when we have time constraint over there, right, we start doing something called as a silly mistake or calculation error, right? And that can be again avoided with the help of calculator, right? The next topic that they might test you on is reflection and translation, right? I'll be discussing all these topics, right, in brief, right? The very small introduction I will be giving you about these topics today, right? Reflection and translation, then you are tested on functions, then we are tested on logarithmics and exponential rules, right? We are tested on trigonometry, right? Now when I talk about trigonometry, right, they talk about the basic trigonometric ratios, the basic identities, that is sine square theta plus cos square theta is equal to 1. Then they talk about the unit circle part. Then they talk some basic little bit about the sine law and the cosine law, right? The knowledge of sine law and cosine law is required, but again, right, no in-depth knowledge is required for this, right? The next thing that we are tested on is geometry, right? Geometry is one portion that is really tested properly, right? You have around 8 to 10 questions in ACT that comes only from geometry. Right. The next thing, right, that they are tested on some higher level topics, that is the horizontal asymptotes, vertical asymptotes, and also we can say the inequalities, graphing, right? They test you on this, right? Then they test you on statistics, right? But statistics is a topic, right, that can be easily be dealt with the help of GDC, right? So you are able to understand that whatever I am trying to say is that GDC plays a very important role in ACT math, right? But yes, the number of questions are more, so the fatigue factor also gets generated. But what helps you exactly again? Like the GDC helps you in order to tackle that fatigue factor, right? The next thing that we are tested over here is permutation and combination. We are also tested on probability, right? So this is some broad syllabus about the ACT math. Right now, when I talk about, let's say, progression, right, what exactly do they test you on progression, right? They test you on arithmetic progression, they test you on geometric progression, right? The basic knowledge of arithmetic progression and geometric progression is required. What is that basic knowledge, right? They do test that whether you know Tn and Sn or not, right? They do test for GP, right? Whether you know the formula for Tn, whether you know the formula for sum of n terms, and whether you know sum of infinite terms, right? And then they check you with the basic word problems based on simple interest, compound interest, or population problems, or population, you can say growth and decay problems, right? Or they can also test you on some radioactive problems, right? So these are some basic things, right, that are being tested, right? So you can understand only the basic information about the topic is required, right? No in-depth knowledge is required. Right. Second thing, right, they might test you on, let's say, graphs, right? Now, when I talk about graphs, right, they might test you on linear graphs, right? And specifically, they put more focus on quadratic equations and quadratic graphs, right? Now, when I say quadratic graphs, right, or second degree graphs, I'm basically talking about the parabolas, right? Now, when I talk about parabolas, right, I hope you guys understand that it is given by y is equal to ax square plus bx plus c, right? And when I say it is ax square plus bx plus c, right, we can clearly say that over here the sum of roots is given by minus b by a, and product of roots, right, is given by c by a, right? This is a quadratic function, right? And this I am writing it down for a quadratic equation, right? The next thing, right, that we should know over here is the value for d, right? What exactly is d? We know that quadratic equation can be solved by splitting the middle term, or it can be solved, right, using the quadratic formula. Right now, when I say quadratic formula, right, what exactly is quadratic formula? It is minus b plus minus root of b square minus 4ac over 2a, right? Yes. So when I say minus b, this is a quadratic formula, and in this I can say something written inside the root, right? It has a value that is d, right? So d is equal to b square minus 4ac, right? Again, right, we have three cases for that, right? We say that d is greater than 0, d is equal to 0, and d is less than 0, right? When I say d is greater than 0, I say that it should have real and distinct roots, right? When I say d is equal to 0, we say that it is real and equal roots, right? And when I say d is less than 0, I say that it is a case of imaginary roots, right? So you can understand, right, it is touching upon everything, right? See, when I talk about quadratic equation, we learn how to solve the quadratic equation also, and we even learn how to solve the quadratic equation using the formula also, right? And we touch upon the values of d also, right? So everything has been touched upon. The knowledge is required, right? The knowledge of everything is required, and your GDC is there for you to support it, right? The next thing that we discuss over here is the translation and the reflection part. Right now, when I talk about translation and reflection, right, what does exactly translation and reflection expresses, right? I can say reflection, right? For example, I have this as the x-axis, right, and I have this as the y-axis, right? Now, what is happening? I have a point over here that is 2, 5 that is reflected about the x-axis, right? So when I say reflected about the x-axis, that means it is getting flipped, right? Or I'm trying to generate a mirror image of that, right? So when I'm trying to generate the mirror image of that, right, I can clearly understand that 2,5 when reflected about the x-axis, right? My x value remains the same, but my y value gets reflected and it becomes a negative value, right? So I can clearly say that reflection about the x-axis, right, my y value changes to negative y, right? And when I say reflection is happening about the y-axis, I can say that x changes to negative x, right? So when it is reflected about the y-axis, right, I can say it becomes negative 2,5, right? This is a general theory of reflection, right? If you understand this much in reflection, right, no more information in reflection is required. You will be able to easily tackle any question in ACT. Right now, next thing, if I talk about translation, right, now what exactly we should know in translation, right? See, if I have a curve, let's say y is equal to x square, my curve looks like this, right? Y is equal to x square, right? Now what exactly happens to this curve, right? Some basic information, right? If I translate this curve, let's say 3 units up, right, what will happen to the new equation? My new equation turns out to be x square plus 3, right? That means when you go upward, some value gets directly added to it, right? And if I say I translate this graph, let's say 4 units to the right, what will be the new equation? My equation turns out to be x minus 4 whole square, because we can understand that the vertex of the parabola becomes 4, 0. Right? Similarly, if I talk about, let's say it gets translated, let's say left side by negative 6, right? So I can say the equation becomes x plus 6 whole square, right? And if it gets translated, let's say downwards, right? So I can understand, let's say this is 8 units downward, right? So my new equation, right, it becomes y is equal to x square minus 8, right? So I can say that this is nothing but your vertical upward shift, right? The second one I can say is horizontal right shift, right? The third one I can say is the horizontal left shift, and the fourth one I can say is a vertical downward shift, right? So this is how the equation turns out to be, right? This is what is called as a translation part, right? The third thing, right, if I talk about, is a simple thing, that is a scale change, right? Now, if I say scale change, right, so we should be able to understand, if I have a simple graph, let's say y is equal to sine x, right? And if I multiply it with the 2, right, let's say 2 sine x, so what will happen, right? My graph gets amplified, right? Now, when I use the term amplified, I can clearly say that my value on the y part is getting increased, right? See, initially my graph was something like this, right? My graph was something like this. Now my graph has amplified, or I can say that the amplitude of the graph has increased, right? So the amplitude of graph now, instead of 1, right, it becomes 2 now, right? So this is what the scale change part is, right? So again, you can see, right, the basic information of progression, basic information of quadratic equation and parabolas, basic information of translation and reflection is required, right, in your ACT math, right? Again, if I talk about, right, let's say they talk about logarithmic and exponential functions, right? So when I talk about logarithmic and exponential functions, right, what they test you on, right? They test you on a knowledge that if you write y is equal to a to the power x, right, a is nothing but, right, the base, right, and x is nothing but your power, right? Now when I say x is nothing but your power, right, I can understand over here that if I talk about the domain and the range part of it, right? So as we understand, domain is something, right, domain is something that can be input, right, inside the function, and range is something that we get as an output, right? So when I talk about the domain, right, domain is all positive, domain is something that you can plug in, right? So you can plug in anything over there, right? But since, let's say if I take an example of y is equal to 2 to the power x, right? So whatever value I plug in over here, right, in place of x, my output is always going to be positive. So my graph of exponential function look like this, right? So I can see that range is all positive real numbers, right? But instead of this, if I take a base, right, that is less than 1, right, I can understand as the value of x increases, my base becomes much smaller and smaller, right? So I can understand that my graph will look like this, right? And I have one intersection point over here, right, of both the graphs, and I can understand that this intersection point is nothing but when x becomes equal to 0, the value becomes equal to 1, right? So this is some basic information about logarithmic functions, right? The next thing, if I talk about, is a log function, right? What exactly is a log function, right? If I say I write something as log of base 2 and 8 over there, right? So this actually tests what? It tests that on what base or what power I should put on top of 2 so that I should get a 8, right? So on top of 2, right, I'll put a 3 and so that I get a 8, right? So I can understand that this value over here becomes equal to 3, right? And when I talk about the base of the logarithmic function, right, if this is my basic logarithmic function, I know that my a is always greater than 0 and my a, right, that is the very, very common understanding that on the base of 1, right, if I take base of 1 and if I write here, this is never possible because base of 1, right, on power of 1, what I can put so that I can get a 8? We cannot put anything, right? It can never give us a 8, right? So that is why base of 1 is never allowed in logarithmic function. Now, when I draw graph of logarithmic function, my graph looks like this, right? So I can understand that these two are inverse functions of each other, right? These are inverse of each other, and since they are inverse of each other, since we know the property of inverses, right, if this is 0 comma 1, this is going to give us 1 comma 0, right? That means if we have x comma y, right, in a function, right, in the inverse of a function, we will always have y comma x, right? That means I can say that the domain and range gets interchanged, right? And also both these graphs are mirror images about the line y is equal to x, right? So this is your line that is y is equal to x, and both the graphs are mirror images about this line, right? So this is what the basic information about logarithmic function and exponential function is, right? So if I broadly talk about ACT math, right, ACT math is something, right, that has to be started as early as possible, first thing, right? And more practice is required for ACT math, right, because it is completely a time game. We should be able to understand that we have to do 60 questions in 60 minutes and we have to be real fast. Apart from that, right, we have to be more accurate, right? Because at time we try to read the question very hastily, or we try to complete the question in a very hasty manner, we start committing called as silly mistakes. See, for getting a perfect 36 in ACT math, right, what exactly is required, right? If you want the perfect 36 in ACT, right, we have to do the ACT exam without any error, right? It has to be completely error free and all 60 questions has to be correct, right? Because if we do one simple mistake or one silly mistake or calculation error in ACT math, what exactly happens? Our score starts going down, right? We start losing that perfect 36, right? So and this is not something that is impossible, right? It can be easily be done, right? Just by simple practice, right? You need to do proper practice. Proper usage of GDC is required, right? Now, when I use the term GDC, right, what all GDCs are permitted in exam and that can help you the best in your exam? The first is a Casio FXCG50. Right, it's a Casio model, right? It is easy to learn, right? And it really helps you a lot, right? There are certain equations, right? For example, if I talk about 3 equation and 3 variable, right? For example, if I have x plus y plus z is equal to, let's say, 10, right? And if I say I have 2x plus 3y plus 4z is equal to, let's say, 30, right? And I have one more equation, let's say 2x minus 9y plus, if I say 5z is equal to 60, right? And I want to find the values of x, y, and z, right? And if these 3 equation comes in front of us in the exam, right? And if I start solving this manually, we all know, right? It is going to be very long process, right? Manually, it is going to be very long, right? But if I talk about your GDC, right? Your GDC is capable of solving these 3 equations and 3 variables in seconds, right? So these type of questions are actually put in the exam because CBSE kids, ICSE kids, right? They do have a tendency of solving everything manually and mentally, right? But if you have the GDC, you have to start inculcating that GDC in your normal day-to-day life while practicing for the ACT math, right? Because the more you have hands-on experience on GDC, the more better you are going to perform in your ACT math. Right, so this is one permitted model in the exam which can give you maximum benefits. Second is your Casio FXCG20. The third is your Casio 9860G2 version, right? You can also use TI instruments, right? You can use TI Inspire, right? You can use TI Inspire CX model, right? Now either it can be CX1 or it can be CX2, right? Both the models will be absolutely fine, right? The only thing that I can say is, again, right, that it is not an exam that tests your in-depth knowledge about the topics. It only tests about the basic understanding of your topics, right? Do you understand the topics or do you have the knowledge of topics or not, right? See, it also tests you on the higher level topics. For example, if I talk about higher level topics, it tests you on vectors, right? But again, right, when I talk about vectors, right, it only tests you on parallelogram law, and the triangular law, right? So when I say parallelogram law and triangular law, it can be easily be dealt with the help of sine law and the cosine law, right? So it can test you on vectors, it can test you on limits, right? But when I talk about limits, right, the each and every question of limits that falls in ACT math can easily be dealt with the help of GDC, right? So you can understand GDC is a very is a big support in your ACT math, but it cannot do everything for you, right? Because if you don't know what is a concept of limit, you won't be able to deal that question even if you know how to use the GDC, right? Because on GDC, which menu to use and how to use, that can be known to you only if you know the concept of a particular topic, right? So some higher level topics are also dealt in ACT math. For example, it tests you on vectors, right? It tests you on graph of inequalities, right? Graph of inequalities. Then it tests you on conics, right? Now when I talk about conics, right, conics is such a vast topic that it needs a lot of knowledge, right? But again, right, conics is something, it will test you on parabola, right? It will test you on equations, circle equations, right? It will test you on ellipse, and even it will test you on hyperbolas, right? There are questions nowadays, right, that comes from hyperbola also, right? But again, right, some basic information is required. Your GDC is a support, and then you can easily be able to deal with the question. Your question becomes very easy, right? If you know in what menu, where to use which particular equation to be used for which conic question, right? That is what the main agenda is, right? After that, right, see, if I talk about the basic understanding of those 60 questions, right? See, when we start doing the paper, first 1 to 30 questions are really easy, right? We can say directly say that they are sitters, right? These are sitters, or I can say very easy or easy questions, right? But after from question number 31 to 45, what exactly happens, right? The fatigue starts getting generated, right? Because you have already done 30 questions, but 31 to 45, the questions are again easily manageable, right? Till 45, right, you can say moderate type of questions, right? Moderate type of question. And once your final fatigue has been developed, right, from 45 to 60 questions, you start getting all the tricky questions, right? And these are the tricky questions that you get from little higher level math, right? Now when I use the term higher level math, right, I can understand, I think you guys can understand that I'm talking about vectors, I'm talking about inequalities, I'm talking about conics, I'm talking about modern math, that is permutation and combination and probability, right? So these 45 to 60 questions are something, right, that has to be dealt with proper understanding and knowledge of math, with proper usage of GDC. Right now, after that, right, if you ask me, right, what support books should be used, right, for having proper ACT math knowledge, so you can either take a Kaplan or you can take a Barron's, right? Any book can help you with for proper knowledge, right? But one thing I can say, the sooner you start, right, for preparation of ACT math, the better you are going to perform in the ACT math, right? For GDC, right, you can take any GDC which I have asked you to take, right? You can take a Casio, or you can take a TI model, even you can take a TI 84 or a TI 83 model, right? Everything works, right? But you should know how to properly use it, right? If you have any issues anytime, right, that you are not able to understand any menu regarding how to use it, right, all YouTube, there's so many YouTube channel, full YouTube support is provided for learning the GDC, right? But what I can say is that ACT is an exam where proper practice is required in case of math, right? You see, for example, with proper knowledge, and you can say with proper GDC usage, right, reaching out a 33 to 35 is easy, right? But getting a perfect 36 is something, right, that can be done only with help of proper practice, right? You should be able to understand, right, where are those gaps, right? Those gaps has to be completely filled up, right? And those gaps are actually mostly created because of the silly mistakes, right? Now, silly mistakes is something, right, that has to be avoided, right, by using proper GDC and these calculation mistakes, right? Because see, calculation mistake, why do we do? Because we are actually not using a GDC in a question where it was actually, it has to be used, right? So that is something we have to start inculcating this GDC in our normal day-to-day life, right? Once you have started preparation for ACT, the first thing that you should learn is GDC, and while you are solving any mock, any question, any assignment, right, the proper usage of GDC has to be there. Right, this is what I can say about GDC, right? And also, the sooner you start preparation for ACT, the better you are going to do in ACT math. Apart from that, right, ACT math test you on everything, but no deep knowledge is required. It's a shallow exam. Proper, all 60 questions will give you a perfect 36. That is what I can say about ACT. Yes, Helen ma'am, it's over to you now.